So last time we had some examples where we applied DeMorgan's theorem, but they were very simple because they had direct implication of DeMorgan's theorem. Now I want to come up with some other examples. They will be only a bit harder. Let's come up with something like that. Say AB negated plus B multiplied by C negated plus C, say D, both negated. And we negate the whole thing. So, as we can see from this chart, we can apply the version of DeMorgan's theorem for addition, this one, and we can think about this term and this one as A and B in DeMorgan's theorem. So this will equal these terms where we multiply them by each other and negate them. So let's do that. So we have first term, which is AB negated, and then we negate it again as in DeMorgan's theorem. Then we multiply it by this term and negate it. B, C negated plus C, D negated, and we negate this term as in here. And I need to say that very often it's very simple and silly mistake that I do all the time, is that I forget that if you have plus in the left part, then in the right part you will have minus, and vice versa. And you should really try to not forget this fact. So if we had multiplication under the big bar, then we have multiplication on the right side, and vice versa. And so this will equal, then we can apply DeMorgan's theorem for multiplication. For this case, it's nearly the same, except we have bar above B as well. So this term will be A negated, as in this formula, plus B negated and negated again. So this negation is the one right here, and the negation above it, this one, is the negation that we got from the DeMorgan's theorem. Yeah, like that. And we can leave this negation alone, but we also know that if something is negated twice, then it's the same thing. You remember from our first lecture or something like that, that A negated twice equals to A. So we can erase these two bars above B. Yeah, then we have now this part, multiply by, and we also apply again DeMorgan's theorem, but now we think it's also for multiplication. We think we can map DeMorgan's theorem on this equation like this. This is one part of the product, and this is another one, like here A and B are. And so this will equal first part negated plus another one negated, like this. So we open the brackets because we will have separation from the left part, and so we write B and negate it as in DeMorgan's theorem. Then we write plus and negate the right part, which is C negated plus CD negated. Yeah, both negated. And we negate the whole thing. It's, oh no, so yeah, right, we negate the whole thing as in here. And now I think we close the bracket. Yeah, it was one possible way, but another possible way would be to open this bracket inside the negation and then apply DeMorgan's theorem. There are many ways to do the same thing always in math as well as in engineering. So we should check it. We did the right thing. So this is one term, this is another term, like here. Yeah, and we negate it. Right, looks like right. Then what we have, let's go further. Let's rewrite this bracket. Let's not open it the time and deal with these parts. We have b negated plus, and we can again apply now version for addition of DeMorgan's theorem. So we have the result of this will be C negated and negated again as in this formula. So A in this formula will be C negated, then the whole thing will be C negated twice, plus CD. What a pity, we need to negate it twice. I thought that we would solve this one again. But never mind, we already applied DeMorgan's theorem several times. That should be enough for this example. Now we should check it. Yeah, nice, and we made a mistake. And actually, I really often do that, and I saw that people very often forget that by some means, I'm not sure why, but if you had sum, if you had addition under the big bar, then you will have multiplication when the bars are separated. So it's the rule of DeMorgan's theorem. You need to forget it and to look closely every time you do that, so that you don't make silly mistakes. I do all the time, but if you check it, then it's going to be better. It's a very silly mistake. Yeah, but we do that. I hope I didn't do that somewhere here. But then, is that right? Okay, we had addition, and it became multiplication. And we negated each one after we did manipulation. And now we can just erase double negation, and you should know why. Then next, what is it equal? We can now open the brackets, but we can actually do something with this part. I would rather, it's multiplication, so I would rather write it more close to each other, so it's CCD. And you might remember that one variable multiplied by the same variable should be something that we can simplify actually. Can we? Let's see, I actually don't remember. I don't remember all things in Boolean algebra. I usually look them up somewhere. Yeah, so we have A multiplied by A equals A. That means that C multiplied by C will equal C, so we can rewrite this part. This will be only C. Let's rewrite it. We'll take our time. Multiplied by B negated plus CD. And now let's open the bracket. It's not going to be any more DeMorgan's theorem to apply here, but anyway, let's finish it. Multiply A negated by B negated plus A negated by CD plus B negated plus B CD. And again, b negated, that looks like something we can make much simpler. Yeah, it's actually 0. One variable multiplied by the same variable negated equals 0, as we remember from first lectures. So the whole thing will be, this part will be 0. So let's write the thing that looks like it is the answer. Okay, I'm not quite sure that this is the simplest possible version of this example. Maybe we can simplify it further using Carnot technique, and I think you should try it out. It would be interesting. But very often it's normal way to simplify things. First you have some crazy equation with lots of bars, lots of brackets. Then you have several ways to do that. You actually could apply Carnot technique on this directly. Yeah, that's actually a good possibility. You can directly make a truth table out of that and then solve it. But as well, you can first make it simpler by applying DeMorgan's theorem, and then make a truth table out of this one. Because if you have a lot of variables, for example, in this case we have 4 variables, A, B, C, D, right? Then you will have 16 cases. You will have 16 lights in truth table, and that's a lot, and it will be easier to have these cases for this expression than for the one that we initially had, right? But it's up to you. But anyway, it's useful to know DeMorgan's theorem, even though you can do practically everything with Carnot technique. But then I really encourage you to go and make this one or this one and apply Carnot technique. So you can have some full example from top to bottom, from very unsimplified expression to very simplified one. Yeah. So I think that's it for this example.